Section 2.3 is talking about the limit laws. So there's going to be a lot of laws I'm going to go through. And then what the idea of this is now we're going to find limits algebraically. So we've done graphically. We understand what a limit is. In order for the limit to exist, the left side must equal the right side. Left limit and right limit must be equal. And we've really just done it by looking at graphs. Now we're going to do it algebraically. Okay, so this first box of laws is saying what? Saying if I have the limit of two different functions, f of x and g of x, and I'm trying to find the limit as x goes to some number of f of x plus g of x, what can I do? I can find the limit of each one separately, then I can add the answers together. Second one, what's the second one saying? The exact same thing with subtraction. I can separate them, do them separately, and then subtract them. Number 3 is saying if I have the limit as x goes to a of some constant c times f of x, what can you do? You can find the limit of f of x and then multiply it by the constant. Number 4 is the exact same thing as 1 and 2 with multiplication. So multiplication can be broken up. I can find the limit separately and then multiply the answers. And 5 is division. Same thing. Do the limits separately and then divide the two values. 6 through 11, more limit laws. So number 6 is kind of like the other, saying if I have the limit of a function to some power, what can you do? You can find the limit of the function, then I can raise it to the power afterwards. 7 is really important. What's the limit of any constant? That's all this is saying. So for example, the limit as x goes to 5 of 2. Well, this property is saying it's 2. Why? Because this is just a horizontal line. So, any constant, think about y equals 2. That's y equals 2. So the limit as x approaches anything is going to be that number. So the limit of any constant, any number, is just itself. Next one, the limit as x approaches a of just x will always be a. Again, if I think about this graphically, if I think about number 8 graphically, what is y equals x? So we know that for number 8, right here, showing number 8, there's y equals x. So what's the limit as I approach 1 going to be? What's the y value at 1 is 1. What's the limit at 2? It's going to be 2. What's the limit at 3? It's going to be 3. It's always just going to be the same thing as what you're approaching. Number 9 is saying the limit as x approaches a of x to the n will always just be a to the n. We'll talk more about this in a second. This is really like direct substitution. These two are very important. Same thing with 10. 9 and 10 are going to be shown in a second with direct substitution. And 11 is important. It's kind of like composition. If I'm trying to find the limit of the nth of a, this is really the same thing as the number 6. But it's just saying if I have a radical instead of an exponent here, I can find the limit first and then find the nth root of it. All right, this is the most important property. This is what I was talking about, substitution. So if I have a polynomial, so what's a polynomial? A quadratic, a cubic, a quartic, a linear, or a rational function, okay, which is what? 1 over x. 1 over x minus 2. X over x squared minus 4. And a is in the domain of f, then the limit is just going to be f of a. Okay? What the heck does this say? Limit as x approaches 3 of x squared plus 5. So x squared plus 5 is a polynomial. So this is saying that the limit is just going to be equal to f of a, which would be what? F of 3. So all you have to do is take 3 and plug it in. What do I get? 3 squared plus 5. 9 plus 5 is 14. Why is this true? Because if the function is continuous, the limit is just the y value. How do you get the y value? You take x and do what? Plug it in. Do another one. Limit as x approaches 1 of 2x squared minus 3x. All I'm going to do is take 1, plug it into the function. So I'd have 2 times 1 squared minus 3 times 1. 2 minus 3, negative 1. So direct substitution is saying that if A is in the domain of F, as long as I can plug it in, I don't get division by 0, the limit as x approaches that value, all I have to do is plug the x value into the function. All right, so let's try some algebraically. Number 1, limit as x approaches 5. So is 5, can I plug 5 into that? Yes. So the answer to this will just be the y value. How do you get the y value? Plug in 5. Do some algebra. 5 squared, 25, times 2, 50. Minus 15 plus 4. And then I'm just going to do this out. So what do I have? I have 35 plus 4, which is 39. Okay. Number 2, rational function. So again, limit as x approaches negative 2 of this rational function. If I can, guys, I'm just going to plug in the x value. So as long as, now what do I mean if I can? Does negative 2 give me a number, or does it give me undefined? It's okay because it doesn't make the denominator 0. So I'm just going to plug it into the function. We're going to do some algebra. So negative 2 cubed is negative 8. This is going to be plus 8. Negative 2 squared is 4 times 2 is 8 minus 1 over 5 plus 6. So I get negative 1/11. So that's my limit, which really I want you to realize is just the y value when x is negative 2. So this is really a closed point because the function's defined. Whoops, sorry, closed point because the function's defined. Same thing. Anytime you can just plug it in right away, it just means it's at an actual defined point of the function. All right, so let's jump right to it. Well, what happens when I can't? Number 3, I cannot plug 1 in because I would get division by 0. So we're going to go through some different algebraic techniques where I can find this limit algebraically. So the first one is just factor. So if I can, I want to simplify this function so I can plug 1 in. So how do I simplify the function? I have the limit as x goes to 1. Factor x minus 1 times x plus 1 over x minus 1. Look, that cancels. So now this just becomes the limit as x goes to 1 of x plus 1. Now I can plug 1 in. 1 plus 1 is what? 2. So my answer is 2. Why am I allowed to do all of this? Again, important to realize the limit as x goes to 1. I don't care exactly what it equals at 1. The limit is really what am I getting closer and closer to. Now, if you connect this to what we did graphically, this is saying that there's a hole in the graph since the factor cancels. And the y value of the hole is 2. Next one, limit as, that should be h, sorry. Oops, limit as h goes to 0 of 3 plus h squared minus 9 over h. Now, looking at this, I cannot plug 0 in because I'd get division by 0 again. So, a next technique I'm going to show you is just simplify, FOIL. So if I simplify the function by foiling, I'd have what, guys? 9 plus 6h plus h squared minus 9. What I do, I just FOILed and then subtracted the 9 over h. Look, the 9's cancel. So I'm left with limit as h goes to 0 of 6h plus h squared over h. Factor out an h and cancel it. So I'd be left with limit as h goes to 0 of 6 plus h. Now I can plug the 0 in. My answer is 6. Notice that each step I'm writing limit as h goes to 0. Okay, I do not stop writing that until I actually plug the value in and get my answer. Okay, so far we have factor, we have FOIL as 2 different techniques. Next one, limit as t goes to 0, square root of t squared plus 9 minus 3 over t squared. You always want to check. Can I just use direct substitution? No, because if I do, I get division by 0. So, third technique is to simplify this function a little bit, I'm actually going to rationalize the numerator. So I'm going to multiply this by square root of t squared plus 9 plus 3. So that would be the conjugate over, same thing, plus 3. Do some algebra, so I'd have the limit as t goes to 0. When I FOIL the numerator, I'm going to get t squared plus 9 minus 9 over t squared times the square root of t squared plus 9 plus 3. Sorry, I didn't write the t squared plus 9 in here. Okay, so all I did was rationalize the numerator. You got to multiply numerator and denominator by the same thing. Now the 9's cancel, t squareds cancel, so the function turns into 1 over t squared plus 9 plus 3. Now I can plug 0 in. When I plug 0 in, I get 1 over the square root of 9 plus 3, so I get 1/6. Okay, the whole point to all of these algebraically is to do something, simplify the function so that you can use direct substitution after you've simplified the function. Next one, number 6. I'm looking at, so can I plug -2 in? No, if I plug it in, I'd get division by 0. So this is looking like a factor problem. Now the numerator, look at that, our favorite cube formulas. So the numerator is going to factor as what, guys? Remember this, x plus 2 times, x squared minus 2x plus 4. That's my sum of cubes over x plus 2 times x minus 2. Now I get this to cancel. Now I can use direct substitution and plug the -2 in. So what would I have? I would have -2 squared minus 2 times -2 plus 4 over -2 minus 2. Simplify this. 4 plus 4 plus 4 over -4. So 12 over -4, which is -3. So again, simplify the function. Something will cancel or simplify so that I can plug in the value that's needed. Next one. Looks a little complicated. Limit as h goes to 0 of 1 over h times 1 over 2 plus h minus 1/2. So looking at this, I could find a common denominator here. So that's the first thing I'm going to do to simplify this. So I have limit as h goes to 0, 1 over h times. Now I find a common denominator, which would be 2 times 2 plus h. So I'd have 2 minus 2 plus h over 2 plus h. Didn't show all the work there, but my common denominator is 2 times, times 2, I can't write up here, plus h is the common denominator. Okay, so now simplify. So I have limit as h goes to 0 of 1 over h times, numerator would be 2 minus h over 2 plus h. The 2's are going to cancel, so I'd have limit as h goes to 0 of 1 over h times -h over 2 plus h. Now look how wonderful the h's cancel. So I'm left with the limit as h goes to 0 of -1 over 2 plus h. And now I can plug the 0 in. So I'm left with -1 over 2 times 2, which is -1/4. So there's my limit. So just to go back, that's the last algebraic example. Just to recap, what are the ways so far I have to simplify, to do limits? I'm going to write them right here for a second. So what can we do, guys? What are the different strategies? I can factor, I can FOIL, I can rationalize. So I factored, I FOILed, I rationalized, and I used a common denominator to simplify. So these are all algebraic techniques in order to find a limit. And in the end, with all of these different techniques, you're using direct substitution to get the value.